seems that within minutes of an earthquake, seismologists can tell exactly where it happened and how strong it was. Crucial for emergency crews to know where the hardest hit areas likely are. So how can we know this information so fast? Well, you've probably all seen a seismogram before, or at least that infamous seismic signal that seems to go haywire when an earthquake hits. A seismogram is the record of ground movement with the passage of time, and they can detect ground movement caused by a local earthquake as well as a large event far away, because of the fact that seismic waves travel through the earth. Now, seismographs are securely mounted to the surface of the earth, so when the ground starts shaking, the instrument case moves. What doesn't move, however, is a suspended mass inside the seismograph called the seismometer. During an earthquake, the seismometer remains still while the case around it moves with the ground shaking. And we can locate earthquakes using a simple fact. An earthquake creates different seismic waves that radiate through the earth. The different waves each travel at different speeds and arrive at a seismic station at different times. Now, the P wave is the fastest, so they arrive first, and they can move through both solid rock and fluids like water or liquid layers of the earth. The S waves, which travel at about half the speed of the P waves, arrive later and can only move through solid rock, not through liquids. It's actually the property of these S waves that led seismologists to learn that the Earth's outer core is a liquid. Now, since we know how fast these seismic waves travel, a network of interconnected seismographs can quickly pinpoint the source of a quake by measuring the difference in time it takes these first two waves to reach a detector. And these measurements allow scientists to estimate distance, direction, magnitude, and the type of earthquake that just occurred. Now, there are many other kinds of waves that follow the first two, including surface waves that only travel through the crust of the earth. These are the waves that are almost entirely responsible for the damage and destruction associated with earthquakes. And while we may never be able to predict earthquakes in a meaningful way, it's this property that the non-damaging waves arrive at seismograms before the damaging waves that allows us to give some kind of warning that shaking is on the way. Not a lot of time, but 30 seconds is enough to get into a safe position. Japan has this early warning system in place right now, and both BC and California are among other places that are in the initial phases of testing. But knowing what to do in an earthquake will always be important. The Great British Columbia Shakeout is on October 16th. Sign up your family, school, or company to take part in BC's largest earthquake drill at ShakeoutBC.ca.